All right, guys, today we're going to look at solving equations. So we're still in the review mode here, but we are going to talk about things a little bit differently than you might have learned in the past. So the first thing you want to do is just distribute, combine like terms, do all the simplification. So let's do that first. We'll just look at number 1. So 6 times n is 6n. 6 times 5 is 30. All right. Look on the left side, no like terms combined. Look on the right side, no like terms combined. And when I say side, I'm talking about the sides of this equal sign here, the left and the right. You can't mix them up. Don't try and add 30 to those two because they're on opposite sides of the equal sign. Can't mess with it. So now what I need to do is isolate my variable. I need to get it by itself. So to do that, you're going to add, subtract, multiply, divide, whatever you have to do to get this n by itself. And we're going to do subtraction and addition before we do multiplication and division. So I'm going to subtract this 30. So 6n is equal to negative 28. Divide by 6. And again, you're going to get some improper fraction. That's fine. I do want it simplified, though. If you don't know, well, 28 and 6, they both have a 2 in them. So it's going to be negative 14 thirds. You could, of course, just type that in the calculator and it'll simplify it for you. All right, so let's see a more interesting problem. Let's look at number 4. So we got all kind of mess going on here. The very first thing we want to do is distribute. So I'm looking in here. I see this nasty fraction I need to distribute. Just do it. So negative 16 equals. All right. So let me grab my calculator here because I don't like messing with fractions. I have negative 15 sixteenths. And remember, the parentheses we're distributing, that means multiplication. So times this 4/5. So of course you can't put variables in this in the calculator while you're doing this. You can solve this entire equation using the calculator just by typing it in using the solve function. But I want you for now to take your time and show the work. So I'm gonna do that. And you know, if you're familiar with how fractions work, you can see, oh yeah, it's gonna be 3/4. Because the 15 divided by 5 is 3, and the 16 divided by 4 is 4. So that's how we got the negative 3/4 right there. So that's negative 3/4, but don't forget the q. He hasn't gone anywhere. And then I'll just do this one. That's going to be 10 minus 10. Negative 15 over 16 times a positive. So negative times positive is negative. 15 over 3 is 5. 32 over 6 is 2. 5 times 2 is 10. Now it looks a lot nicer. However, we still have a fraction. If you got a fraction, you're going to want to get rid of it. So you're going to need to multiply by the LCD. So after you distribute, go ahead and figure out what your LCD is if you still have one, if you still have a denominator. That does stand for least common denominator if you forgot. So this denominator is understood 1. This denominator is understood 1. So I've got a 1, a 4, and a 1. 4. That's the only denominator I really have. 1 doesn't really matter. LCD is 4. So I'm going to take my LCD and I'm going to multiply it to each and every term. Remember, a term is anything separated by an equal sign, an addition or a subtraction sign. So I have 1, 2, 3 terms here. So 4 times negative 16 equals 4 times negative 3/4 q minus 4 times 10. All right, so that's going to be negative 64. Again, you are welcome to use a calculator. Equals Now, we're clearing the fractions, so we better not have a fraction whenever we're done here. 4 times 3 is 12, divided by 4 is 3. So that's going to be negative 3 cubed. You could also see the numerator and the denominator are going to cancel one another out. If after your LCD you still have a fraction, you did something wrong. Either it wasn't the LCD or you multiplied by a fraction incorrectly and you need to use your calculator. Okay, now we've got a basic equation just like this was. Oops, wrong button. Sorry, give me a second. And it froze. Let's go back. There we go. Sorry about that. Okay, where were we? Here. Here's where we were. So now I need to isolate my variable. You can get on the left side if you really are more comfortable that way. It doesn't matter. Just get it by itself. So I'm going to add 40. You could, of course, get the q to the left side first. Entirely your choice. I like just leave my variable where it is unless it's convenient to move it. So it's negative 24 equals negative 3 cubed. So now I have a negative 3 being multiplied to my cube. I'm going to divide by negative 3. I get 8 is cubed. So that's my answer. Okay. Let's see. I think we'll do number 10. So this one, we'll do number 9. That one's more interesting. So this one, if we look at it, we do have the distributive property in here. And I'm sorry, this line is not part of the problem. That's just from the previous box. So it's just this fraction bar right here. So yeah, we have a distributive property in the numerator, but we also have a denominator here we need to take care of first. So I could distribute, sure, why not? Let's do it. I've got an understood negative 1 there. So I need to go to that x and that negative 9. So that's going to be minus x plus 9. Remember, a division bar is a grouping symbol. So you can think about this as a giant set of parentheses. So you can do this first. Order of operations is still valid here. So 10x minus x is 9x. 17 plus 9 is 26. And it's over 2. Didn't do anything to the right side. Okay, I've done my distributive property. I've simplified this understood parentheses up here as much as I could. But I still got a fraction. I need to get rid of it. So I'm going to do is multiply by my LCD. This whole thing is divided by 2. This thing's divided by 1. This thing's divided by 1. And by thing, I mean terms. Look. Let's look at how many terms we have here. This is a grouping symbol, don't forget. So this whole thing is one term. Now I have an equal sign, so that's my second term. I have a plus sign, so that's my third term. This only has 3 terms. Don't think that this is 2 terms just because there's a plus sign between them, because this division bar is grouping them together. So let's look. I have a denominator of 2, so that's my LCD. So I'm going to take 2. I'm just going to multiply to these things. 9x plus 26 over 2. I didn't really need my parentheses, and if I wanted to, I could even put my parentheses all the way down. Doesn't matter. Equals, as long as you understand it's multiplication. That's what to do here, so you could just put a dot and put it like in the middle-ish. Plus 2 times 1. Now I could distribute the 2, that would be 18x plus 52. but that's more work than we need to do. Remember, we're trying to get rid of the fractions here, so let's do it. 2 divided by 2 is 1, and 1 times anything is itself, so that's just 9x plus 26 equals 6x plus 2. Now again, you can get your variable left side or the right side. It doesn't matter. Get it by itself. Isolate it. So I'm going to subtract 6x because, well, I like positive numbers. And if I subtract a smaller one, I'm going to get the positive out. All right. So I got 3x plus 26 is 2. I need to subtract 26 from both sides to get rid of that. 26 minus 26 is 0, nothing, nada. So it's just going to be 3x plus 0, so it's just 3x equals negative 24. Divide through by 3. I get x is a negative 8. So again, this should not be new to you. Now, the whole LCD thing, the way I write it out, that might be new to you, I don't know. But it shouldn't be. This should all be familiar, at least. Now, let's look at a couple special cases. So I'm going to do these kind of quick. So 1 plus 3c equals 5 minus 5c plus 8c. So if I look over here, I get 1 plus 3c. If I have over here 5 plus 3c. If I try and isolate my variables, they're gone. And I'm left with 1 equals 5 because the 3c's are just canceling each other out. Does 1 equal 5? No, it doesn't. So our answer here is no solution. And we can represent that in a few ways. If we're doing set notation, it would be the empty set. So I usually draw mine like that. You might also see this. That stands for the empty set. All of these mean the same thing. Ain't nothing gonna work for this equation. Let's look at this one. 40 minus 8x equals negative 8x plus 40. Okay, if I add 8x to both sides, I get 40, oh wait, the x's are gone, equals, oh, the x's are still gone. I get 40 equals 40. Does 40 equal 40? Yes, it does. When does 40 not equal 40? It always equals itself, doesn't it? So our answer is everything. Real numbers. You should remember the symbol for all real numbers is that. We talked about that the first day. It's been a little while, but that's how we represent this set of real numbers. And in interval notation, we would see negative infinity to positive infinity. So that's everything from negative infinity all the way up to positive infinity. So that's everything. I'm not sure how familiar you are with interval notation. So we'll have to look at that more closely. We'll take a hold of the classes. And here we have proportions. Now I know you've seen these problems before. You've seen them in my wife's class, except they didn't have x's on the bottom. You've seen them in geometry whenever we're doing trig. However, some of your classes might have told you to cross multiply. That doesn't fly here, no. Anytime you have a fraction, multiply by the LCD. So this one's a little trickier. Let's just write out the LCDs first. And in fact, you don't really have to use the LCD. You can always just use a CD, a common denominator, and it'll still work out for you. Now, if I look at my denominators, I've got a 3 here, And I got an x plus 4 there. Well, that's my common denominator is just the product of those, 3 times x plus 4. If I had a denominator, let's do a more simple example. The LCD of a half and a third. Well, you might know that that's 6. Well, how do we get the 6? Well, we have a 2 and times a 3 gives us 6. So if we just multiply our denominators together, that will give us a common denominator. It might not be the least common denominator, but it will always be a common denominator. So you can always just multiply your denominators together. Now, if you got x's going on, then you could get some crazy equations out of that. So you might want to try for the LCD if you got multiple x's in there. Let's look at this one. So 5x minus 9, I can't simplify that. So if we can simplify it like this one, we can factor out a 2, but that doesn't change anything at all. See, if this x minus 4, if that was an x minus 4 here, it would be simpler, but it's not. So our LCD is just these two guys multiplied together. And so I'm going to multiply this times both of my terms. Cheat a little bit. So I've got my LCD times 10, let me change the color. 10 over 5x minus 9 equals my LCD. And I just like writing it on the left. You could write it on the right as well. 8 over 2x minus 8. Now remember how fractions work. If we are multiplying and dividing by the same thing, well, those just cancel each other out. Anything divided by itself is 1. Same thing on this side. So all I have to do is rewrite it. And I like putting my constant out front. And yes, as you can see, all we did was cross multiply. But that's how cross multiplication works, is through multiplying by the LCD. That's the actual way you have to do it. If this wasn't a simple proportion, cross multiplying would not work, so don't get in the habit of doing it. 20x minus 80 equals 40x minus 45. Wow, I multiplied 5 times 9, so 8 times 9, 72. Get my x's on one side. I like positive x's, so I'm going to subtract 20x from both sides. You don't have to. You could get to the left side if you're more comfortable that way. It doesn't matter. And then I need to add 72 to both sides. I get 8 is equal to 20x. Divide through by my coefficient, which is 20 in this case. I can simplify. Both of these have a 4 in them. So that's 2 over 5 is equal to x. And now, you have to be careful. Sometimes you can get an answer that doesn't quite work. This case isn't so, but you always want to check and make sure that your answer, the 2/5 we got here, if you plug it into these denominators, it does not get you a 0, because if it does, you'd basically be dividing by 0, And you can't divide by 0. Because what's anything divided by 0? Yeah, undefined. We don't know. Can't do it. So if you plug in the 2/5 into both of these and check and make sure it's not 0, you're good to go. It doesn't. So let's move on.